Students, in last session we were discussed up to example number 3. Today I am going to explain example number 4 from our textbook. Let's see the question first. Find a quadratic polynomial. The sum and product of whose zeros are -3 and 2 respectively. We want to find a quadratic polynomial. We know a quadratic polynomial having two zeros. In this question, the sum and product of whose zeros given -3 and 2. -3 and 2 are not zeros. They are sum and product of whose zero. We know two relations. One is sum of zeros, alpha plus beta is equals to -b upon a, and alpha into beta is equals to c upon a. The sum and the product of two zeros are given. Let start by assuming two zeros for this quadratic polynomial. Let alpha and beta are zeros of required quadratic polynomial p of x. We know the standard form of quadratic polynomial. P of x is equals to ax square plus bx plus c. Line between the page. Left hand side sum of zeros, and right hand side we have to write product of zeros. First is sum of zeros, and left hand side we have to take product of zeros. Sum of zeros is equals to alpha plus beta, and product of zeros is equals to alpha into beta. In this question, sum and the product of zeros are given. Alpha plus beta is -3, and the alpha into beta is equals to 2 respectively given. First is the sum of 0 and second is the product of zeros. Alpha into beta, product of 0 is 2. Now see, from our formula, both denominators contain same a. A means the coefficient of x square. Here -3 and 2 has no denominator. That's why we have to put 1 and 1 in both denominators. On comparing alpha plus beta with -b upon a, -b upon a, and alpha into beta on comparing with c upon a, alpha into beta is equals to c upon a is look like as -b upon a, and only c upon a is equals to minus remains as it is. Instead of 3 we have to write b upon a. In right hand side c upon a. Both denominators are equal. Both denominators are equal. A 1 1. Now on comparing -b upon a with -3 upon 1 and c upon a with 2 upon 1, we get three values a, b and c. A is equals to, both denominators are equal, a and a, 1 and 1. Then b is equals to minus, compare with minus. Then b is equals to 3. B is equals to 3. And c is equals to, see the numerator, c is equals to 2. C is equals to 2. Therefore, required quadratic polynomial. We know the standard form. P of x is equals to ax square plus bx plus c. Now we substitute the values of a, b and c in this form. Instead of a is equals to 1 x square as it is, plus instead of b is equals to 3 x as it is, plus instead of c is equals to 2 is equals to 1 multiply x square is equals to x square plus 3x plus 2. It is our required one quadratic polynomial, but we know there are lots of polynomial that the sum and the product of whose zeros are -3 and -2. Sorry, not -2, only 2. Therefore, in general, required quadratic polynomial is k into bracket our polynomial x square plus 3x plus 2, where k belongs to R minus 0. K does not equals to 0 or k belongs to R minus 0. K belongs to any real number but not to a 0. It is an example to find a quadratic polynomial that the sum and product of whose zeros are given. Now let's see the example number 5. Now see example number 5. First of all, the question: verify that 3 minus 1 upon 3 are the zeros of the cubic polynomials. The three zeros are given. 3 minus 1 and minus 1 upon 3 are the zeros of cubic polynomial. We have to verify it first. The quadratic polynomial is given. P of x is equals to 3x cubed minus 5x square minus 11x minus 3. And our second question: and verify the relationship between the zeros and the coefficient. First task is we have to verify three numbers are the zeros of given polynomial or not. We know how to verify the given number is the zero of the polynomial for yes or no. We have to find the value of this polynomial at 3, at minus 1 and at minus 1 upon 3. If we get value of this polynomial at three different numbers is 0, then we can say that these three numbers are zeros of the given cubic polynomial. First of all, we write the given polynomial. Given polynomial P of x is equals to 3x cubed minus 5x square minus 11x minus 3. Let's start from first number 3. P of 3. We want to find what value of this polynomial at x is equals to 3. If answer of P of 3 is 0, if P of 3 is equals to 0, then we can say that 3 is the zero of polynomial. The next step, we need to find P of minus 1. If again P of minus 1 is equals to 0, that's why we can say that minus 1 is the zero of this polynomial. Same as for third, minus 1 upon 3. P of 3. Now we substitute 3 instead of x in all terms. 3 instead of x is equals to 3, cube remains as it is, minus 5 instead of x is 3, square remains as it is, minus 11 instead of x is equals to 3, minus 3 as it is, 3. First simplify the power. 3 cube, 3 3s are 9, 3s are 27, minus 5. Square of 3, 9, minus 11 3s are 33 minus 3 is equals to 27 3s are, we need to multiply 27 by 3, 3 7s are, 3 2s are 6, 81, 27 3s are 81 minus 9 5s are 45 minus 33 minus 3. 81 remains as it is. 45, 33 and 3 having same sign. Then we do addition here. It gives minus 81. 81 minus 81, both are opposite numbers. Then subtraction is 0. P of 3 is equals to 0. Here P of 3 is equals to 0. That's why we can say that 3 is the 0 of given quadratic, cubic polynomial. Now we go for next number, minus 1. P of, instead of x we have to put minus 1. P of minus 1 is equals to 3 as it is. Instead of x is minus 1 cube, minus 5 as it is. Instead of x is minus 1 square, minus 11 as it is. Instead of x is equals to minus 1 and minus 3 remains as it is equals to 3 as it is. Cube of minus 1 gives minus 1, minus 5. Square of minus 1 gives 1, minus minus plus 11 minus 3. 3 multiply minus 1 gives minus 3, minus 5 ones are 5, plus 11 minus 3 as it is. Now see, minus 3, minus 5 and minus 3, by adding them we get minus 11, plus 11 remains as it is, and we know minus 11 plus 11 gives 0. Here P of minus 1 is equals to 0. That's why again we can say that minus 1 is the 0 of given polynomial P of x. Now last one is remain minus 1 upon 3. We have to substitute minus 1 upon 3 instead of this x. P of minus 1 upon 3, bracket is over, is equals to 3 into bracket minus 1 upon 3 cube as it is, minus 5 into bracket x square means minus 1 upon 3 whole square, minus 11 instead of x is minus 1 upon 3, and last minus 3 remains as it is equals to 3 minus 1 upon 3 cube. Cube of minus gives minus, cube of 1 is 1 and cube of 3 is a 27. Bracket is over. Minus 5 remains as it is into bracket square of minus gives plus, 1 upon 3 square is a 1 upon 9. Minus minus plus 11 ones are 11 upon 3 and last is minus 3 is equals to, see here the cut is possible, 3 9s are, remaining into the next step minus 1 upon 9 minus 5 ones are 5 upon 9 plus 11 upon 3 and last minus 3. To simplify this 4 terms we have to take LCM here, and our LCM is 9. That's why minus 1 as it is, minus 5 as it is, plus instead of 11 we have to multiply 11 by 3, 33 minus 3 multiply with the 9, 9 3s are 27 is equals to plus 33 remains as it is, minus 27 minus 5 and 1 gives minus 33 upon 9. Plus 33 minus 33 is equals to 0 upon 9. We know 0 upon 9 is equals to 0. That's why P of minus 1 upon 3 is equals to 0. Here we obtain 3 different values of this polynomial at 3, at minus 1 and at minus 1 upon 3. In all we get 0. That's why we can say that 3 minus 1 and minus 1 upon 3 are the zeros of this cubic polynomial. First question is verified here. Here P of 3 is equals to 0. Second, P of minus 1 is equals to 0. And P of minus 1 upon 3 is equals to 0. Therefore, 3 minus 1 and minus 1 upon 3 are zeros of given polynomial. Now we go for our second question. Our second question is verify the relationship between the zeros and the coefficient. We know how to verify the relationship between zeros and coefficient in quadratic polynomial, same as in this question. First relation, first is sum of zeros. Sum of zeros is equals to symbolic form alpha plus beta plus gamma. We know alpha plus beta plus gamma. Alpha plus beta plus gamma is equals to minus b upon a. We know the values of alpha, beta and gamma. Alpha is a 3, beta is a minus 1 and gamma is a minus 1 upon 3. We have to substitute here. Is equals to, instead of alpha is 3 plus instead of beta is minus 1 and instead of gamma is equals to minus 1 upon 3. 3 plus minus minus 1 plus minus minus 1 upon 3. Again by taking LCM, whole denominator contains 3. 3 3s are 9, minus 3 1s are 3, minus 1. 9 minus minus 3 minus 1 gives minus 4 upon 3 is equals to 9 minus 4 is a 5 upon 3. See here, in this formula contain minus single time, but 5 upon 3 having no minus, that's why we multiply 2 times as a minus is equals to minus, or you can also write in this step minus of minus 5. Minus of minus 5 gives the plus 5. Minus 1 minus as it is, but instead of minus 5, instead of minus 5, we have to write b on comparing ax cube plus bx square plus cx plus d. Therefore, b is equals to minus 5. Here is a b upon, instead of 3, 3 is equals to a and here is a. Now, what are the coefficients here? A and b. A is the coefficient of x cube and here b. B is the coefficient of x square is equals to minus remains as it is equals to minus remains as it is. Instead of b, coefficient of x square upon, instead of a is the coefficient of x cube. Here the first relationship is verified. Now the second is sum of the product of zeros taken 2 at a time, and we know how to write symbolic form is equals to alpha beta plus beta gamma plus gamma alpha. We know the value of alpha, beta and the gamma is equals to, instead of alpha is 3, instead of beta is equals to -1 plus instead of beta is equals to -1, instead of gamma is equals to -1/3 plus instead of gamma is equals to -1/3 and instead of alpha is equals to again 3 is equals to -3 minus plus 1/3 plus minus 3/3. Here the cut is possible, but stay as it is. By taking LCM, our LCM is 3. 3 3s are 9, minus 9 plus 1 minus 3 is equals to -9 minus 3 gives -12 plus 1/3. -12 plus 1 is equals to -11/3. Now we compare alpha beta plus beta gamma plus gamma alpha with the formula alpha beta plus beta gamma plus gamma alpha is equals to, we know, C/A. -11/3 represents C/A. On comparing C/A with this, the quadratic polynomial, -11 is C is equals to C/3. 3 is equals to again A. But C is the coefficient of x, upon A. A is the coefficient of x cube, coefficient of x cube. Again, one relation is incompleted here. First portion is not required now. I remove it. For third relation, you have to continue from last. Last relation is product of zeros is equals to alpha into beta into gamma, where alpha is equals to 3, beta is equals to -1 and gamma is equals to -1/3. Minus plus, 3 1s are 3, 1s are 3 and upon 3. Again see here, minus is not in numerator, multiply 2 times with minus and upon 3 as it is, and we know alpha into beta into gamma is equals to -d/A. It is our rough work for this relationship. See here, -3 and see this bracket -3 is equals to d. Outside minus as it is, instead of this bracket we have to put d, and denominator 3 is equals to A upon A is equals to minus. Now what is d and what is A? Here d is the constant term and A is the coefficient of x cube. Minus d is the constant term upon A is the coefficient of x cube. Hence the second question, verify the relationship between the zeros and the coefficients, is also done here. Example number 5 is not so important and it is optional from our examination point of view, but is very easy to understand. In next session we will discuss about the next examples.